Hello everyone, my name is Rayhan Akmal from Mathematics Education, University of 11 Maret. In this video, I want to explain about limit theorem. First, why do we have to study this material? Okay, let me explain. Most students will agree that proving the existence and values of limit using the epsilon delta definition of the preceding section is both time-consuming and difficult. That is why the theorems are so welcome. And mastering this material is very big help for students in solving for the limit of functions without doing the tedious process of making the table of values and illustrating the graphs of the function. In these lessons, we will be learning the limit theorems and apply them in solving for the limit of algebraic function. Okay, next. Okay, so there are three limit theorems. First is theorem A, or the main limit theorem. The second one is theorem B, or substitution theorem. And the last one is theorem C. Okay, first, theorem A, or the main limit theorem. Let n be a positive integer, k be a constant, and f and g be functions that have limit at c. Then there are 9 parts of this theorem. Number 1, called the limit of a constant. The limit of a constant is itself. If k is a constant, then the limit of k as x approaches to c is equal to k. Okay, next, number 2, called the limit of an identity function. The limit of function fx is equal to x as x approaches c is equal to c. Number 3 is simply just substitute the k from the product of the function to the product of the limit. And next, number 4 and number 5 is kind of like similar to each other. They called limit of the sum and difference of two functions. This states that the limit of the sums or difference of two functions is simply the sum or difference of the limits of the individual function. Number 6 and number 7 called limit of the product and quotient of two functions. Yes. It states that the limit of the product or quotient of two functions is simply the product or quotient of the limit of the individual functions. Note, for limit of quotient, the limit of the denominator should not be equal to 0. In cases where the denominator is 0, the limit doesn't exist. Next, number 8, called limit of the nth power of a function. This states that the limit of function with power n, where n is any integer, is simply the limit of the function raised to the power n. The next, last, number 9, called limit of the nth root of a function. This states that the limit of nth root of a function is simply the nth root of function of the function, provided that if n is even, the value inside the radical sign should greater than 0. Okay, let's move on. And next, the next slide is application of the main limit theorem. So let's see it. Now you can see the example. Okay, number 1, find limit of 2x to the power of 4 as x approaches to 3. To solve this problem, we can use theory number 3 to get 2 times limit x to the power of 4 as x approaches to 3. And next we can use theory number 8 to get 2 times limit x 2 times limit x as x approaches to 3 to the power of 4, and then we can substitute x for x equals to 2 to 3, and we will get the solution is 162. Okay, example number 2 is limit 3x squared minus 2x as x approaches to 4. For solve this problem, first we can use theory number 5 or the difference of two functions to get limit 3x squared minus limit 2x, both them as x approaches to 4. Next, we can use theory number 3 to get 3 times limit x squared as x approaches 4 minus 2 times limit x as x approaches to 4. Next we can use theory number 8 to get 3 times limit x as x approaches 4 and squared minus 2 times limit x as x approaches to 4. Last, we can substitute the x at 4x equal to 4, and we will get 3 times 4 squared minus 2 times 4 is equals to 40. Okay, next example number 3. Find limit of square root of x squared plus 6 all over x as x approaches to 4. Or solve this problem, first we can use theory number 7, the question to get limit of square root of x squared plus 9 as x approaches 4 over limit x as x approaches 4. Next, we can use theory number 9 and 2 to get square root of limit x squared plus 9 as x approaches to 2 over as x approaches 4 to 4 over 4. Next, we can use theory number 4 to get 1/4 times square root of limit x squared as x approaches to 4 plus limit 9 as x approaches to 4. Next, we will use theory number x and 1 to get 1/4 times square root of limit x as x approaches to 4 squared plus 9, plus we can use theory number 2, and we will get 1/4 times the square root of 4 square root of 4 squared plus 9 is equals to 5 over 4. Okay, example number 4. The problem is if limit fx as x approaches 3 is equal to 4 and limit gx as x approaches to 3 is equal to 8. Find limit f squared x times cube root of gx as x approaches to 3. The solution is, first we can use theory number 6 to get limit f squared x as x approaches to 3 times limit cube root of gx as x approaches to 3. Next, we can use theory number 8 and 9, and we will get limit the function of fx as x approaches to 3 squared times the cube root of limit function of gx as x approaches to 3. And we know that the value of limit fx as x approaches to 3 is equal to 4. and limit gx as x approaches 3x equal to x, and we can substitute them and we will get 4 squared times the cube root of x is equal to 32. Okay, next the theorem P, or substitution theorem, says that if f is a polynomial function or a rational function, then limit function fx as x approaches to c is equal to fc, provided that fc is defined in the case of a rational function. This means that the value of the denominator is not 0. Note that theorem P allows us to find limit for polynomials and rational function by simply substituting c for s throughout, provided the denominator of the rational function is not 0 at c. Okay, let's see the example. Okay, the example, find limit of 7x to the power of 5 minus 10x to the power of 4 minus 13x plus 6 all over 3x squared minus 6x minus x as x approaches to 2. Now, for solve this problem, we just substitute the x for x equals to 2, and then the problem is equal to minus 11 over 2. So easy. And next, theorem C says if fx is equal to gx for all x is in an open interval containing the number c except possibly at the number c itself, and if limit function of gx as x approaches to c exists, then limit function of fx as x approaches to c exists, and limit function of fx as x approaches to c is equals to limit function of gx as x is equal to c. Okay, let's see the example. Example number 1, find limit x minus 1 all over the square root of x minus 1 as x approaches 1. To solve this problem, we can factoring the function on the top, and we will get the square root of x minus 1 times square root of square root plus 1, and both of square root minus 1 is eliminated, and we will get limit of square root of x plus 1 as x approaches 1. And last one is we will just substitute x for x is equal to 1, and then we will get square root of x plus x is square root of 1 plus 1 is equal to 2. Okay, now next example is find limit x squared plus 3x minus 10 all over x squared plus x minus 6 as x approaches to 2. Yeah, we know that theorem P doesn't apply because the denominator is 0 when x is equals to 2. When we substitute x equal to 2 is in the numerator, we also get 0. So the question takes on the meaningless form 0 over 0 at x is equals to 2. When this happens, we should look for some sort of simplification such as factoring. Yeah, we just factoring them. And then we will get x minus 2 times x plus 5 all over x minus 2 times x plus 3. Next, we can eliminate x minus 2, and then we will get limit x plus 5 all over x plus 3 as x approaches to 2 plus 1, we can substitute x for x is equal to 2, and then the solution of the problem is 7 over 5. Okay, that's all for this lesson. I'm really sorry if my speech is bad. Yeah, just a learner, and I'm really sorry if in my word there are some mistakes. Thank you very much and see you.